Hi everyone. So it has been a long time since I made my last FPA tutorial. So I'm gradually coming back again to let us know more details, especially some of the basic functions to use FPA. So this time I'm going to teach you how we can use a user-defined function in FPA. Oh, by the way, so right now I am actually starting my own startup. My startup company name is Vibra Power. I haven't made my own startup company website, but sooner. So Lab 2701 is my PhD supervisor, his startup company. So right now we are actively collaborating together. But for my startup, I'm mainly doing vibration energy harvester. So this time, a user-defined function in Anodyne. So that will be very useful since when I was working along my PhD program, I figured that, okay, if you understand how to use a user-defined function that can in FPAA, it can help you to save a lot of your time. So this functionality you can think of, okay, we can use it something like a microcontroller functionality that is embedded into FPAA. So just a very quick example, but in the future you can use whatever function you want. So let's say you want to create a cosine 2x in FPAA, but we don't have a direct function that can generate that. So what you can do, if we go to FPAA again, so if we insert a new cam, the name will be transfer function, close to the bottom, this one. It's called transfer function. Make sure your clock frequency, so it always have this mean and also submean clock frequency. So choose the correct combination that will solve the problem. So it said, okay, a intervoltage transfer function profile by pressing the lookup table function. Let's click on the lookup table function, and you can say this pop up a single column which you can modify the values. So you can do it in two different ways. Either one way is you can just tap it directly by your own from the keyboard. Right now the value 0 from your keyboard is at 2. It changed the value, right? So but there are, let's say, more than 200 values you have to tap one by one. So there is another easier way. So you can indeed put your values into an Excel sheet, save it as a .csv file, and then you can load it from here. So you see there's a button said load. So right now, let's say we say cancel. I will use MATLAB to generate a very quick column vector. So let's go to MATLAB. So in my case, in my case, as you can see, I have already generated a vector in MATLAB. So if I click run, so I already have the column vector y. Make sure your input is from -3 to +3 because that's the FPA working voltage range. So let's check our column vector. What you can do, say copy from MATLAB, but you can also generate directly from Excel sheet. Since I'm more familiar with MATLAB, I will right now open up a Excel sheet. In Excel sheet, let me replace the new ones. So right now you have the new ones. Though I have already generated this before, but just want to show you the details. So make sure in total you should have exactly 256 values because the FPA, this user-defined function, are using in 8-bit. So 8-bit means if you go to MATLAB, 2 to the power 8, the number is 256. So if you have exactly 256 numbers that can be input into the transfer function, then you are good. So let's go back again. Sorry, I forgot to save just now. I said okay. Save the clock frequency. Go to your lookup table. That's easy. and say load and find your CSV file. Make sure the file is saved in CSV. I have tried some other ones, but as you can see, FPAA also suggests the recommended one is the .csv file. Sometimes if you save in CSV file, it also wouldn't work. There are two different types of CSV file. So let me show you what I mean. So I have encountered this trouble before, and I figured, okay, sometimes if you save it in different CSV file, it will give you some trouble. See file, click file, says save as. If you see here, there are two different CSV files. This one is the old version. Don't use this one. I tried. If you use this old version, FPAA will just give you an error and quit. So instead, save it as, let's say, I think there's another CSV here. This one. It's called comma delimited. This is the correct one. I save as this one. So right now, let's go back and go to lookup table and click load and say open. You see all the values right now are loaded correctly from the first one until the last one, right? So say I click OK, we can say apply and OK. Since FPAA itself, it said requested is from the one you entered, but the realized you will always have some error, but this error is small enough, less than 1%, so that's great. Let's say click OK. And also OK again. Let's say a quick example. What if I have a sine wave here? Let's say we insert a new cam, go to oscillator, let's say, where is the oscillator? Oh, here, sorry. It took me some time. Its font size is too small. Sine wave oscillator. Frequency for right now is fine. Let's choose frequency 8 kilohertz. Okay, doesn't require that slow. That's fine. 40, let's say 60 kilohertz. And the amplitude, let's say we choose 3 so that it can vary from -3 to +3. Since it is a single phase, if you don't like the single phase output, what you can do, you can insert a new cam and use the sample and hold. It's called hold here, sample and hold, sorry. Frequency 4000 is fine. Maybe the clock frequency doesn't match. 250, okay. Right now it matches. So let's say we have two output. One is a direct input from the sine wave. One is the output from the transfer function. Let's run the simulation. So the simulation, since that's the phase 1, I guess maybe it might not be a good one. This time is so slow. So I think what you can do, maybe I need another sample and hold here. Not a very good idea. Since this one, I guess, let's increase the setup simulation time. Let's say we'll set 500 microseconds. And we'll try it again. I mean, you can still see the transition since it's a phase 1. So during another phase, I think it's the input trouble. It's just the input trouble. So, but you can easily solve it by matching up the phase.